All right, we're going to talk in Chapter 6 about mapping descriptions and drafting parcel boundaries for cadastral mapping. In Chapter 4, we talked about section, township, and range and how to describe a property. But another method of describing property, as you should know, aside from the fractions of a section, is a meets and bounds description. So a meets and bounds description is a description that begins at a point, follows the boundary around the lines of a parcel around the perimeter, and then goes back to the beginning. Each of those lines is used a bearing and a distance, and then a beginning point that's tied to a permanent location, such as a section corner or a street monument, or a lot and block or something like that. As you might know, they're 90 degrees from north to east. There's 60 minutes in 1 degree and 60 seconds in 1 minute. So there's also we use the quadrant bearing, so north 29 degrees east, that's in the northeast quadrant. But there's also another type that's called the azimuth bearing, and that uses 360 degrees, and you can see a diagram here on page 6-1. So 270 degrees would be directly west, 90 degrees is east, 180 is south, and 0 degrees is north. That's very rare, but could be occasionally used. So just note that 360 degrees, the full circle, could be used to determine the bearing. So measurements are normally given in feet and hundredths of a foot. That's 2 decimal places. So the symbol for a foot is just a single quote. But sometimes other measurements are used. They can use links, chains, rods. Sometimes you could see miles or meters. But most often, if they're not feet, I've seen links, chains, and rods, and those conversions are there. A link is 0.66 feet, a chain is 66 feet, and a rod is 16.5 feet. So an example of a meets and bounds description. This first example that we have here is the same example that we used in Chapter 5 when we rotated a bearing or rotated a description. We're going to use this description, and this is the one we're going to draft later on in this section to talk about it. But it's in the northwest quarter of Section 23. You can see it, the full description there, and the drawing of that there on page 6-2. So something that wasn't in that description is curves. So curves are often in meets and bounds description. You can see some of the points of the curve here. So you saw that graphic of the curves. Let's talk a little bit about some of those points. The arc of the curve is also the length around the curve that goes from one point to the other. We have the chord, which is the short distance, so it's the straight distance between the beginning of the arc and the end of the arc, often called the long chord. The chord also tells you the bearing and the distance, so at what angle is that curve and which way is it pointed. We also have the radius, okay, so that tells you how curvy the curve is, how big the arc is away from a straight line. So there's some other points, but those are the most common points of a curve. Those are the most things. Point of tangency, that's also commonly used, and that's when a straight line and a curve meet and it continues on. So that's the point of a tangency. So examples of curves in a meets and bounds description. Sometimes the curve is concave, and sometimes the curve is convex. And our example here, example 2, kind of shows the construction phase of the curves. You can see some of the dotted lines on page 6-4. The dotted lines kind of show the radius and the chords that of the two curves that are in this description. If you flip the page over, you can see the full completed drawing without the radius and the chord lines and things like that. So that's what that original description, example 2, would look like if you drew that. On some occasions, though, the curves don't give a long chord, and sometimes it's assumed when it's totally void of information that it's a right angle to the last course given, and that's when it's a tangent curve. Like I said, it's the curve is the radius is at a right angle to that course. So an example here is example 3. It gives that information. You can read over that legal description and see that the right angle would be right there down by the page number, where that radius would be as we go along that description. So let's actually draw a meets and bounds description. Let me switch camera angles and we'll show you how to draft the 6 steps of that. We're actually going to show you that example 1 of that. So here we go. Okay, I'm going to draft the description, the example meets and bounds description from your manual. We're going to show you how to draft that here. I've got some graph paper. I've got a pencil. I have a scale here, and I have my land measure compass. You can use a protractor, but that's what we're going to use. And I've got my description off to the side here that I can use as a reference that I'm going to be reading. So we're going to start there. So we're going to do this at 1 to 50 scale. So I find my 50, and this is the side that I'm going to be using for that. So there, I kind of know what my description is going to look like because we have a little example here. And so I'm going to put my section corner. I'm going to post that, or I'm going to put that up here in the top left corner. So we're going to say that this right here is our section corner. So we'll do that, and we'll label that. The northwest corner of section 23, Township 5, north, range 2, west. So we're going to take that. You know what? Let's zoom in a little bit. Let's see if we can do that. There we go. Okay, so our first call says beginning at a point which is south 106.37 feet. So south, if we put our thing in, we're gonna use we're going to use our lines here on this graph paper to help us know. So we know that north and south are these lines, and east and west. So this right here are essentially section lines. Okay. So as we go there, so that's the section lines that we go with. So we're going to go south. So we know it's along this line, and if we had if we were drafting on a plat map, that section line should already be there. For this purposes, we're assuming that south is directly there. So we line it up with 0 on there, and we're going to go 106 feet. Okay, so I like to come down here 105, 106. Okay, so that's where I want to go. 106 feet. Okay, see that? So we ended right there. I hope you can see that on the camera. Yep. Okay. And east 72 feet. So we're going to go east. I'm going to flip it so that I can see it on here. The nice thing about these rulers is the top numbers go 0 this way, and then it starts over here on the bottom numbers and goes 0 this way. So whether you're using it this way or this way, you can still use the ruler there. So we're going directly east, and it's kind of in between. So I'm gonna mark that. Directly east. And see these lines right here. The lines on the land measure compass. You can see this dark line. You can line that up. That's the north, south, east. But you can also use these other lines in here and up here, so you can line it up using any of those lines as well, and you know that your compass is straight. That's another nice thing about the land measure compass. So we're going to go right here, and we're going directly east. Line it up. So we have that. Another thing I did, I don't know if you guys can see this, but see, I put a piece of tape in there and I put a dot so that I can tell where the center of it is. Maybe it's easier that way if I can get it. The light has a glare on it. Anyway, but there's a dot there, so I can tell easy where the center is instead of just having this big hole. It's kind of a cheat way to do it, but basically I took it on a graph paper and lined it up and said, hey, okay, where's the center, and stuck a dot there so that I can see it. It makes drafting much easier, much faster, and it's still, my arm still turns and everything, so kind of a nice thing. So we're going east. So now that we have our dot, we know that that's where we're gonna start. We're gonna go from here to there. That's how we know our bearings. And we're still on 50, and we're going 72.48 feet. Okay. So we go 72 feet. And we go like that. That's how we do that. Okay. So we have south, then we've got east, and this right here is our point of beginning. So I'm going to write point of beginning right there, that POB. I don't usually do that, and usually these are just, when we draw these are usually just tick marks to get to the point of beginning, and then that's when I usually start drawing. But for this purposes, I want you to be able to see those lines. But when I'm actually drafting on the Mylar, I just use little tick marks that can easily be erased and without disturbing any of all the parcels around it already. So now that we're at our point of beginning, you can see so far we've got the same lines here. We've got the same lines here as we do over here. So, and then we're going to go running thence north 73, 44, 45. So when drafting by hand, really the degrees and minutes is, you get the degrees for sure, and the minutes, because this land measure has degrees and half degrees, so you can kind of tell about, so if you have 60 minutes in a degree, then if you're at 30, you're at half, so you kind of get that. So we're gonna put that here, line it up with our lines, make sure that everything is equal right there. And you can see my blue line is not quite on my black line, but it's running, it appears like it's the same distance the entire way down, so I'm parallel to that. So then I'm going to move my arm to 73 degrees northeast. So we go north 73 degrees. Okay, so we have 70 right here, and we have 71, 2, 3, and it's 44, so it's a little over half. Oops, I bumped my compass. So I'm actually gonna pull it up here, and we're gonna go to 73. And a half degrees. Line it back up. I've got some stuff in the way, so it's a little bit easier to draft on my normal desk. Okay, so we've got it lined up. So we're going to make a tick mark right there. So in the drawings that some of you may have seen, you may see my little tick marks out to the side. That's okay. Usually when we're drafting, those just get, like I said, those get erased. So now we're going from here, our point of beginning, over to our other line, and we're going to go 75 feet. So we put the end of this on 0, line it up with that line, and 75 feet is right there. Okay, so we've got that line. So now we line up our same thing. Now we're going thence south 16, 15, 15, east. So south 15 right there, 15 degrees. So we've got our compass all measured up. Put our little center dot on that point, make sure that everything's lined up and we're running straight. And we're going to put our dot down here. Okay, so now we have our bearing from that end of the line to our new point, and we're going to travel 120.87 feet. Now with measuring similar to this, where we can't get the precision, to the hundredths or tenths of a foot, we just draw to the nearest foot, and at this scale, you're not going to tell a difference anyway. So We'll go to 100. Okay, line it up. 120. So then we stop at the 12. Right on the 12, because that's 120. Okay, so far we've got to our point of beginning and the first two calls down, and it looks similar to our thing, so we know we're kind of going right. This is nice to have that there, so we kind of can see our example. The homework assignments that we have for the drafting part won't have examples, so you won't know what it'll look like, but we'll show you that after. So let's continue on with our next call. Is south 80 degrees west. So we're going to go punch it right over here to south, and we move it 80 degrees towards the west. Okay, just like we do. Line up our dot. It's almost right on that line there. You can see right here, this line right here lines up with that blue line, so I can use that to help guide, and then this line right here lines up with that blue line, and so those two make it so I know, and my dot's on the center, and I'm at 80 degrees. You don't always have to use the arm too. You can just come over here and push the 80. You know, I do that frequently. I don't even use the arm. I just come and make the tick mark to wherever, you know, and that works as well. The arms sometimes help if you have different scales and things like that. So we've got our second tick, or another tick mark there. And this time we're going 75.45 feet. So a little bit tricky. We're gonna have to flip it around, and I'm gonna have to lean in here. Sorry if I bumped the camera. So we're gonna go 75, so let's put it at the 0. Line up our line. We're gonna go 75 feet. I think that's 75. Yeah, right there. Okay, so about 75.45, bent just a little past half. So now most, you could be tempted just to finish your line here, but we want to make sure that our bearing closes. So we want to go north. Our last call is thence north 16, 15, 15, west 112 feet. So let's come over here to 16. We line it up. We can see our line actually goes right through our point of beginning over here. We're going to put our point right there because that's where our thing is, but we know it's going to go right through there. And now let's check our distance. And our distance should be 112 feet. And 11, 112, and 8, and lo and behold, it works. I've drawn this one a couple times, so you can see that we have our description. It does match. We're at 1 inch equals 50 feet. So this is to scale. We should write that in here. 1 inch equals 50 feet. And we're going to put our north arrow in there, north, so we know which way we're supposed to be going. Okay, so that's drafting the description. So that's how you draft by hand. We'll try it with a couple of different other descriptions. Hopefully you've had a chance to get all of your materials that you need, and we'll go from there. All right, so you saw me draw all the first 5 steps. So now let's move on to step 6, and we'll talk a little bit about the rotation and how to rotate the description. Okay, so we've drawn our description, and we talked about drafting a description at a 10-degree rotated angle. Now I've gone through and done a little bit of math, and I've already drawn a rotated angle. But for our rotation, we want to use this same description that we just drew, and I actually took the liberty of already drawing it. Same principle that we've done here, but I already drew it up. So let me pull that up. There it is. So I drew it up on a piece of graph paper. Okay. You can see, you know what, let me pull out this other one that I drew of our original description too. So you can see both the descriptions. This is the original one, just like the one we drew here. It's just in ink, so it's probably a little bit easier to show up on the camera. And this one is our rotated bearing. So we take our rotated bearing, and basically we did the same thing. We came here, but instead of going directly south, you can see that we went south, and there's our tick mark right there at 10 degrees. South, 10 degrees. Okay, then we came over here, and instead of going 90 degrees, we went 80 degrees. Mathematically calculating that, and you can see my tick mark there, went 80 degrees right there. So you can see that rotated the whole description that way. Okay, so so we have that, and I have two. I went ahead and I photocopied them on a transparency, so it makes it easier. So I'm going to show you how to rotate the bearings, and you can see that it's just a copy of what it is. See all of my oops, and my light is shining, but you can see all of my grid marks. Once we line them up, they're all there, so you can see the photocopies of the grid marks and everything as well. So we have that, and I'm going to show you how you rotate it. So this is going to act kind of like the Mylar, and I actually have an original one as well. Our original description. Well, let's just use our this one right here in ink so we can see it. So if we line it up right there, we can see the two different rotations. You see that? I'll tip it a little bit so there's not a glare. So we've got our two different rotations there. Our original, which is underneath, right here, and our rotated, which is on top. So mathematically, if we take them, and you can see that it's drawn at that angle there. It's not straight. So if we take it, we can mathematically and adjust it, but we can also just rotate the bearing like that, and bam. So see this line right here that we want? This line should rotate with our section line. Okay? So our pencil drawing under there, can you see that pencil drawing? It's a little bit lighter. And we can rotate that. We rotate right at the axis right there of the section corner. So we keep that, and you see how we just rotate that? So that's where it was originally drafted, and we physically rotate it, and there it is. It matches up just perfect. So we don't need to mathematically do it. We can just draft it on a graph paper, and we can mylar, and stick it under the mylar, adjust it so our basis of bearing matches up with the section line, and then we know where we are. And then if our original drawing were underneath and our mylar were on top, then we just draw it. So no different than say here's our drafted version right here. If we drafted it on our paper there, and this is our mylar with our original. Okay, so just the same thing, but we're gonna keep our original in the same place, and we're gonna rotate. Oops. Yeah. So we're going to rotate our drawn to match our mylar section line. Same thing. So whether you're lining your paper up or your mylar, as long as they're lined up, then you can draw on your mylar and you can trace it, and you go, okay, that is where my section corner is, or my parcel is, based on the section corner. So rotating, made simple without all the calculations. The other nice thing about it is by rotating it this way is that you don't have the liability for all of the math. So if you're not great at math and you could potentially make a math error, this kind of but you can still draft okay. This will take that out, because you can just physically rotate it and take out all of your math error. And you can see that if you've done it correctly, they should be the exact same. But much easier to draw it as the description originally is, so you don't have to worry about all that math. And much faster too, because the time it takes me to do all the math versus just rotating it, so much easier. Alright, so that's how you rotate a description manually. Okay, welcome back. We're back to this camera angle. So let's continue on. We've talked a little bit about drafting them and rotating them. Let's talk a little bit about how precise the descriptions are. So some legal descriptions are not as precise as others, and they may have problems with closing perfectly. This actually happens more frequently than we would like, but it does happen. So the example here that we have, and there's really nothing we can do to improve that legal description. We can only show what is reflected in that, and we assume that the party owns a parcel of description that actually closes. But we're going to kind of nickname those a bad description. So a description that doesn't completely close, or something else is wrong. So we're just going to call them a bad description. So you can kind of see that in example 1, that our starting point and our ending point, which should be the same, doesn't match up. There's a 30-foot error in the closure, which happens occasionally. So the illustration here represents the two parcels. The larger solid line represents the parent parcel, which is a bad description. Okay, and then we get a smaller parcel that's kind of the dotted lines there that you see. That's created by a survey description, and it's a parcel that's being broken off or split off from that. And so, for all intents and purposes, the two parcels can be represented as shown at the top of page 6-15. But when you kind of figure some of those things out, you have to take in some other considerations. The boundary of the adjacent parcels. How are they lined up? What's theirs? Maybe some natural or physical boundaries that are called out by documents that says to the canal or to the road. We've had several issues of those in Box Elder County. Railroads, right-of-ways, fences, ditches, etc. Anything that's a physical feature that can tie that otherwise bad description to a physical point and maybe clear up some of that information. Also, the reciting boundaries called out on previous conveying documents. So it could call a description and say, such and such by record. So it ties to a previous thing. So some of those are considerations that you have to take into account as you're drawing some of these descriptions. And so we talk about this up here, this parcel, the bad description parcel, because it doesn't close by 30 feet. We have a little bit of latitude to locate that smaller parcel and kind of use your judgment to figure out where that is. Here in example 2, we have the opposite. Instead of the ending point and the starting point overshooting it, we have it undershooting it. So it doesn't quite go to the end. You can see that the solid line again represents the bad description owned by party A. Party A sells to party B via new description, which closes and is represented by the dotted line. And it would seem reasonable to show party B as the new owner and also change the old description to the correct description on the tax rolls. But again, there's other things that need to be considered. So when we do some of those things, we have to again take into consideration the boundaries of the adjacent parcels of the bad description. It may follow exactly the lines of the adjoining properties for that bad description, and so those lines really should be honored. In such a case, the new description might encroach on some of the neighboring boundaries or result in a remnant description from the original description that would leave it with party A owning a little piece there. Other things, again, natural or physical boundaries that we talked about, and also tying to other previous boundaries. Again, so those same things need to be in consideration when we do that. So moving forward, oftentimes we'll get a description, and then party A sometimes will sell something to party B, but it won't be the same description as their full piece that they own. And so we're going to call those splits. Sometimes they're called break-offs, but oftentimes we're required to map that new description. So in this example here that we have for parcel splits. Party A is going to is the owner of the following described property. You see the meets and bounds description there and the drawing there on page 6-17. And then on the next page, Party A is going to sell to Party B a portion of that. Okay, so we have that description there. So, and you see it begins, you see the beginning point for the original description is in the southeast corner, but the new beginning description goes further along that, goes up there, and so begins where in the middle of the west line that was of the original parcel. And so we have kind of that mapped area. You can see that the description then runs northeast, 100 feet, then north's 170 feet, then southwest 100 feet, south 170 feet to the point of beginning, and it leaves kind of a remainder description there. And so how do you describe that remaining parcel? Okay, so there's two really common ways that counties have for describing that, and it's usually about half and half. About half the counties do it one way, half the counties do it another. You might have a unique way to do it, but we're going to talk about the two common ways to describe that remainder parcel. And describing a remainder parcel is important. You need to know how to do that. It's going to be part of your everyday responsibilities. It will also be on part of the test, describing a remainder parcel. But the first way to describe a remainder parcel is to use the original description that we had. So that original description that's on page 6-17. And then, so you describe that whole thing, and then you say less the new description. And so that's one way to do it. That's the way I do it. That doesn't mean that's the right way. But the other common way to do is to calculate the distances based on the differences between those two descriptions and write a new remainder description for that. And you can kind of see on the example on page 6-18, you can kind of see the mathematical difference between that. Because this little jog at the top is 15 feet and we went 170 feet to the top of that, 170 minus 15 is 155 feet. But we're going the opposite way, so instead of going north, we're going south 155. Then when we started that piece that we were originally selling off to Party B, we went northeast. We're going the opposite direction, so it's southwest, but it's that same bearing, it's that same distance, 100 feet, and then we go south 85 feet there, and we go the northeast the 200 feet to close that off. So you can kind of see in this example it was easy to calculate those based on math. Sometimes it's not so easy. But whatever you do, here's the example of those two on page 6-19. You can see the two differences in those remainder descriptions. Either one would work. They both correctly describe the piece of ground. So whatever your county recorder is comfortable with for you doing is the way you should be doing those. But understand both the ways to do it. So even though in my county we do it with the lesser, I still understand how to write that description and do that. So let's talk a little bit about subdivisions. We talked about subdivisions in chapter 1 when we talked about the Utah Code, and both in the county code and the city code where it talks about subdivisions. But when a subdivision is recorded, they have to have an accurate map made of the subdivision with a survey. We have an example here of the Cherry Ridge subdivision. But the subdivision operates to call out or dictate all of the streets, easements, alleys, other public places that would be in that. It also splits the land into the lots shown and the lots above. A description, another way to describe a piece of ground in a subdivision might be lot 76 of the Cherry Ridge subdivision phase 3 as shown in Box Elder County, Utah. So that would be an appropriate legal description because it refers to that subdivision plat and a lot within that. And so because they can define what that piece of ground is based on that subdivision plat, that would be an acceptable legal description as well. Another acceptable one would be platted town sites, meander lines, riverbanks, other things. It could be lot 6 of the riverbank tract, whatever. Here we have an example here of Plat O of the Tremonton survey. So you can see that the lots and blocks there in that plat. So an example of one of those might be lot 3, block 2, Plat O of the Tremonton City Survey in Box Elder County, Utah. An acceptable way because we have that defined area of that town site survey. One of the jobs of the cadastral mapper is to map out the proper ownership, and so an example there on 6-22 is an example of the county recorder's ownership map developed using using elements of drafting and surveying and other mapping. You can see there's some that are hand drafted, some that refer to surveyed sections, the surveyed portions of subdivisions. Sometimes they're there, and so, but that's an example of a recorder's ownership map. So, oftentimes in legal descriptions, we may use abbreviations and other things, but in the Utah Code, it gives us the opportunity to use abbreviations. So we've got a list of some of the common abbreviations here on the page, 6-23, and also a land conversion guide that's there. So it helps to have that. The biggest thing that I want that you're going to have to know for the test from the abbreviations and the measurements is how many square feet are in an acre. Okay, so you'll need to know that 43560 because you'll need to do the conversion. You've done a lot of that. Hopefully you know that by now because you had to do it for most of the map. But you'll need to know that. I don't know, maybe I shouldn't tell you that. I just gave away something you'll need to know. So that's okay. So let's talk a little bit about the homework. Okay, I believe that's everything in the chapter. Yeah, let's talk a little bit about the homework. The homework for the drafting and mapping section here for chapter 6. We've got a couple of descriptions for you to do, I believe, and I provide you with the paper to draw them on, so you can draft them right there on your homework. If you're printing them out, make sure you don't scale them. It's a PDF, so if you scale it, set it to none, I believe, as the note there on the download says. Otherwise, your scale will be off and none of your parcels will fit. Learn that the hard way. But make sure you do that. They'll be a little off. But we've just got a couple of meets and bounds descriptions in the lots and blocks. We've got a few there, and then some in the Section Township and Range, and I believe there's also some legal descriptions that you have to answer. Let me see if I can find it. Yes. Yep. So yeah, a couple. There's a few. It looks like there's 4 parcels in the lots and blocks, and 7 of them in there. This should be no problem if you've done the cadastral mapping. The reason there's so many is because if you haven't done them drafting by hand, this will get you good practice, because the drafting by hand will be on the test. There won't be this many, but there will be a few of those on the test, and also remainder descriptions will be on the test as well. So understand how to do those, and that's really the purpose of the homework, is to help you understand the fundamentals of what would be on the test, and to help you make sure you have the skills required to be a certified cadastral mapper. So try and do those, and we'll meet again. See if you have any questions on mapping by hand. All right. See ya.